Hello. Good morning. Or evening. Or afternoon. Mid-afternoon for me. It's approximately 3:06 p.m. Meaning that it's really late for everybody else. Shocker. Anyway, so I'm very unprepared. What we need to do is we need to make grabber part 3. I can write. Now, you'd see that you can grab it like this, and then you can make it shorter, and then you can read it better. Wow. Isn't that revolutionary? Wow. Wow. Anyway, we need to make grabber part 3. So let me hop into Fusion 360, make it big, and click the button. Wow. Oh wait, hold on. Wait, hold on. Nope, that's my. Hold on, what's my keybind? There it is. I have a keybind for chat. Okay, anyway, we need to make grabber version 3. I'm not gonna worry about how tall it is. I'm just gonna make it good. Not like, I just want it to work. I don't care about how tall it is. I'm not gonna worry about the issues that I had before with the like height and whatever. I simply just want it to work. And if it needs to be an extra like 15 millimeters tall for it to work, then so it has to be an extra 15 millimeters. That's okay. It can be an extra. I just have to make sure that it works. Is the important thing. Like if it cuts my card sorting robot like capacity by a chunk, then so what? I simply will make it taller. The solution, make it taller. Instead of trying to fit everything, like the square peg into a round hole. Except in this case, I can just buy a bigger round hole and put the square peg through that, right? So let's make that bigger square hole. Let me check grabber 2 to see where we went right and where we went wrong. Okay, so I realized that pretty much all of the friction problems I was yapping about is from the way the rubber band channel is made. So I reckon that if I designed a better like rubber band channel, then it would be significantly improved in that aspect. Another thing I should do is, okay, so I need to make sure that the belt is in the exact same spot as, because that's how it is on the gantry part, and so I need to match it, right? And then I should also, you know, design a real mount for my limit switch and not just yeah, we'll just put some screws and then like figure it out later kind of deal, you know? And then this thing, I need to design it so that it's actually printable. And so, yeah. So we should figure out what printing orientation am I going to pick. Every single time I've printed it along this face, pretty much. So it's standing vertically. But I'm wondering if that's correct, right? What if I printed it on this face? If you look here, well, no, because that's wrong. It's always wrong. So I think printing it on this face is correct. But like, what if I could design the other part, the other piece, so that it's not printing along that face? Anyway, let's just do the sections that, you know, like that now. So let me get a rectangle. Actually, let me get a rectangle from the middle of this entire thingy. Yeah, we can get it from the circle. That's 96 by 71, huh? So I'll just make that so that I have a good reference spot, because I can use that. Oh yeah, did I tell you guys, I completely changed the way my desk is. I moved everything. Everything is in a different location. Kinda wild. Like, I took my desk, and basically if you take the mirror of the desk, that's what it is now. So I flipped it around the center line. So now everything is on the left, and my work area is on the right. Now, I remember telling you guys about a secret stream, a surprise stream. That surprise stream is gonna be, I'm gonna make a camera mount, a phone camera mount, using the scrap material that I already have. That's what I'm gonna do. And I think that'll be pretty fun and exciting. Okay, so what is it that I need to do? I need to make the, wait, hold on, I've already got center rectangle. So I need to figure out how far... What if it was like 70 by 70, huh? 70... No, it's always gonna be 71 on the width. I don't know. Curious. I'm really kind of tired. I'm gonna be honest. I don't know why I clicked stream, because like I'm really kind of not in it. I'm not in the zone, you know what I mean? So let's see how far apart these are. That's 58 millimeters. Okay. Now I believe this measurement, wherever this measurement is important. So I should make note of that. Is that if I measure this plane and then this circle. Okay, that's useful. Yeah, that's not really useful at all. Can I get the inside of the circle? No. Cool. Okay. Well, let's just take this and create a sketch then. And then from the inside of the circle, I can see just how far it needs to be. 21 millimeters. Got it. Let's go over here. And let's get a line of 21 millimeters. Okay, so this is where our linear rail needs to be mounted. So I'm thinking, let's see. Okay, I don't need to be in the sketch anymore. How long is this? 13 millimeters. Oh, I don't need caps lock either. Okay, so if that's 13 millimeters, let's just get a line. 13. Hit enter. And then, where's the midpoint? There it is. So this will be the midpoint of that. And then, yeah. Wait, okay, so are you telling me it's not properly dimensioned? Why is it not properly dimensioned? This line is dimensioned, and this is... does it need to be perpendicular? No. What is the constraint missing? Oh, I see. Let me just dimension this then. 21. There you go. Now it's dimensioned correctly. Excellent. Next up, let's see here. It's MGN by 12, right? Oh, that. Let me get my ruler to measure my MGN by 12 rail that I have right here. It's like 8 millimeters. So we'll just go with 10 for good measure. Yeah, 10 seems about right. Hello, time. How's it going? Yeah, okay, there's our 10 millimeter line, and then this one. Okay, great. Those are automatically dimensioned. How wonderful. Okay. So this is where our linear rail goes. So how should I get my the thingies going? All right, let's get our center rectangle. So I can figure out how far off this needs to be. So it should be 62 by 71, I guess. Okay. 21 by... Actually, I'll leave that one blank, because then I can just make sure that these are coincident to each other. This line should be coincident. Oh wait. I would like to coincident this line to this point. There we go. Now it will be good. Yes, very good. Next up, we need to add these angled bits, TM. So let's do that, why not? Now, what happens if I... Okay, here's an idea. I'm wondering if I can make this printable without supports. Like, I don't want to have supports in this section with a linear rail, because then it makes it slightly less dimensionally accurate. I'm wondering, what if I just didn't have it be part of the whole thingy? Because I can always insert the screws from like a hole that I model and then tighten it, do that, and then whatever. All right, let's get our doodads going. So this, let's see, what would this be? 130, 135, huh? All right, I would like this to be 135. Wait, hold on, where did the 135? There we go. Hey, where did my angle go? Well, that's okay. I'm not really in the mood for streaming right now, but I've got to get something done. That's okay. Let's get ourselves a line. Now, I believe that if I measure... let's see here. If I inspect... I see this line versus... No. How can I measure this easily? This versus this. Wait, hold on. Let me inspect this line. 12. Alright, chat. What is... No, this is dumb. Okay, what was I doing? We're just gonna call it... Wait, I have the real thing. I can just measure it with a ruler. I am not the sharpest. That is just 1. Okay, it's just 1 centimeter. Very good. Okay, meaning that our line is actually to this bar. So let me actually just get that going across real quick. Then I can coincident it. And then it's mentioned correctly. Great. And then I will do the same thing over here. Let's just get that going. D, dimension this line 10. Great. Okay. Now what happens if I actually make the angled section on the outside a little bit? I think that would be better, actually. Let's look in here just to see what exactly I use that zone for. So I use that area where the angled goes away for this, but it's okay if I just move the angled out. Now for this side it might be a bit more complicated, but we're gonna redesign it so that it's less stupid and idiota. So, you know what? Let's just take this. I'm gonna make this be 5. No, wait, what? Yeah, let's just do 10. Sure, why not? 10 millimeters. And then this one should be 135. And we'll just do that. coincident this and this, or this and this. I don't know how to do it. Alright, where is this not properly mentioned then? What is this parallel to? Parallel to that? No, it's not. Okay, what is this parallel to? Okay, that's frankly quite silly if you ask me. Alright, this got our angle. How is this not properly dimensioned anyway? Auto constrain. Do it for me. Oh, it added that dimension? That's silly if you ask me. What if I just clicked this button, clicked this, and then clicked... Oh, I don't want that actually. Oh, I see that word. Okay, yeah, okay. Let's just get a sketch dimension here to here. And there we go. No, there's a line here that I'd like to delete actually. Is there a way I can grab that line specifically? No. Okay, let's just undo everything so I can get rid of that line. Okay, line's gone. Yeah, this should be 135. There. I did get the right line, right? Okay, yeah. And then let's get a dimension from here to here. Should be 10. There we go. Now it's dimensioned. And then I do the same thing over on the other side. Plane type 45. Get it locked in there. Click the D button. Do that, to do that, do that, type 10. Great. And then on the other side, maybe on the other side I can get away with doing the small one. I don't know. Yeah, maybe I do get away with the small one on the side. It doesn't have to be symmetrical. And if it is, if I do get away with doing a small one on the other side, then that means it's it only goes in one way, which is better for assembly, I guess. That's nice. So yeah, why not? Let's do it. You need a line from here to here. Oh wait, I don't need a line from there to there actually. What I do need to do is create a point at the midpoint. There we go. And then I need to get a line from here to here. 135. From there to there. Dimension this. From there to there. And then we can make this be whatever. Let's just go with 10. Why not? Whatever, right? And then we do the same thing over here. So 45. Get it locked in. Click D. And then this one can be 10 as well. Wow. Okay, great. Okay, can I move that to there? Thank you. Alright. What next? So those are the rails that it will be sliding on. Next up, I need a spot for the rubber band. Now, here's a curious question. What if I put the rubber band, like, right here, where the linear rail goes? Because remember, that's where all the force is going to be. No, we don't need to worry about that right now. This is what we were modeling. So how high up does this need to be? I'm going to take the old one as a reference, 40. Check that out. Wow, what a handsome little fella, huh? Oh gosh. Okay, why is this not... Where is this line from? Where's this sketch point from? Can I delete the sketch point? What happens if I move the sketch point? Freaks out. Oh. Is that for the angle? I guess so, huh? Cool, I guess. Alright, what happens if I... okay, where does this sketch line come from? What happens if I delete that sketch line? Okay, is this good now? Oh, shoot, I made this entire area go away. Okay, well, let's undo that then. And this is why I don't like Fusion 360 sometimes, is that it makes faces where you don't... like, it doesn't get the perfect dimensions. It uses floating point math, apparently. So, like, if I wanted to extrude this, for example, it's not the same face. So it's like, why is it not the same face? What happens if I go over here and click replace face? Like, I can't do that. That doesn't work. What happens if I do... nope. Simplify. No, I don't want to make a box. That's an interesting little bit, but that's not what I want to do. What I want to do is get my stupid line correct. What happens if I just zoom in forever? Okay. Does anyone know how this works? I'm gonna Google it. No, I don't. No, go away, phone. I don't need to. Alright. How do you search for things on the internet again? 360 face split, no reason. Okay, nope. New face when extruding. There we go. I don't think that's a solution. Alright, we're not gonna worry about it. Let's see. Should I just redo my entire sketch then? Okay, this one works. That one doesn't work. Why not? Alright, let's see how far apart these two are. Distance 0.0, great. Yeah, that's not helpful. Cool. You join these faces. That's not helpful. Not helpful at all. Okay, what happens if I this face and then target this one? Oh, that works. Why does that work? Alright, you know what? We can get rid of this extrude. We can fix this extrude so that it grabs all of these guys. And we'll just replace the face. I choose this one, and I choose that one, and it goes away. Wait, what? Huh? Okay, I want to grab that one. This face, replace these ones. There we go. Oh, right, that seems to have fixed it. Hello, Castron. I'm using... Actually, it's really simple. I'm just using a bunch of end stops and a Raspberry Pi camera. And the idea... So what I've got here is I'm working on a new version of it. And so the idea is that when you pick up a card, basically this entire outer section moves up, and then you can click the end stop. And basically, I was just gonna use the G-code probe command. OpenCV, it's I have to use some sort of machine learning. I believe it was it's been a while since I worked on it. I don't know if OpenCV is a step in it. I'm sure it's somewhere because OpenCV is like, you know, the thing. But like, it's my computer, my hard drive got completely deleted. Well, actually, my computer hard drive died. So it's on GitHub, but I don't have anything. I don't have any of the. I can't check right now. Basically, is what I'm trying to say. But yeah, basically, when it contacts a card, the entire this body will move up, and then it will, you know, flick the switch that knows it's at the end. I'll use a G-code probe command to figure out exactly where it, you know, needs to go. I'm just gonna spam the G-code probe command and hope it works that way. If it doesn't, well, then I'll have to actually do some you know, because that's the part that I'm really worried about, is the mechanics. I was just gonna use gerbil because it's basically a CNC machine. You'd like to see, hold on, once it loads, there we go. This is what the frame looks like. So it's literally a CNC machine, but with only two axes for now. I'm not doing a third one because it would be, I need one that I need a minimum viable product, and then I can get on to making, you know, a better one. And so that's what this is. It's just you know, left and right, there's where one of the end stops are. And then on Grabber version 2, the end stop, you know, I was gonna design a new like face or plate for it to mount there, but this entire thing was doo-doo, so I'm doing a version 3. Yeah, wow. So, yep. Where was I? I need to see my sketch again so I can eat it. Let's go back into our sketch. I'm gonna get some lines like that. Okay. Now I can extrude. You know what? Let me check the one that I made already. I see. So yeah, it is like that for now at least. How far is that? That's 1 centimeter, right? Yeah, that's 1 centimeter. Okay. New body. Okay. This is the part that attaches to the linear rail that's moving up and down. It's backwards. Basically, the linear rail carriage is being mounted to the gantry, and then the grabber part is attached to the linear rail, and it moves up and down to balance the counterbalance. Why is my rotational center there? Can you be normal Fusion 360? There we go, I figured it out. Okay, basically, I have a badge holder. Like, you know those badge holders that people at like companies, I'm unemployed. People at companies use to like tap in to the building doors. I have one of those. And that's our ring that doesn't follow Hooke's law, basically. Even though it does, it follows the law at, you know, such a distance where it doesn't really matter. Anyway, we need a new sketch here for our doodad, our suction cup mounting point, the correct term for it. So let's figure out those dimensions. I believe that's 0.5, and yeah, and then how that is a circumscribed hexagon of what appears to be 14, or inscribed of, I can't tell. Inscribed of 12. Yeah. Wait, I think I have them backwards. I get them backwards every single time. Yeah, it's a circumscribed of 12. Cool. Let's get our 6. Also, I should angle it so that when I print it, it is not impossible to print. So let me figure out how do I do that in Fusion. Okay, there it is. Okay, so let me actually just measure the real thing that I'm doing. Yeah, 12 seems to be about right. So we'll make this be 6. There we go. And then I'm gonna need a circle of, we're gonna make it be 11. Good measure. I mean, that's not for good measure, that's for the threads, but it's M10. I have a nut though for the other side, so it just needs to be snug. It does not need to be, you know, threaded into the plastic or anything like that. Anyway, I think that's good for that layer. So the first thing I'm going to extrude is I'm going to hide body 1. We'll go up this 5. Actually, you know what? I'll grab this too, and we'll go up 10. Yeah. And then let's go back down here. And then we'll move this one up -5. Oh, never mind. We're just gonna move it 5. Cool. There we go. Oh, that reminds me. Nope. Alright, let me create a new sketch actually really quick here. And then to make this doodad printable, I'm actually gonna make this be at an angle. I think 60 degrees is a fine angle to 3D print at. So let's just do that. And then we'll do it here as well. That's 120, right? Okay. There we go. See, that's why we made it a little bit wide here. If we make it wide here, if you look at Grabber version 2, you see how this is flat because of how skinny I made it. Since I made it so skinny, you have to use supports in here, and then it becomes like less accurate. If I do this, then I don't need supports, and it should also be more stable because reasons TM. Actually, it might be less stable because the rotation is more square and at more of a, I don't know, it doesn't really matter. Besides, it's pressing down on a rectangle. It doesn't need to be like perfect. It will be pushing on a rectangle, yeah, so it's okay if it's a little bit quirky. Okay, let's get some more rectangles going. Create the sketch. And then let's get some lines just cause. Think about here's fine. No, it's not. Well, okay. We should. All right. Here's what we're gonna dimension this 5. Then I'm gonna do the same thing on the other side. 5. Okay. Yeah, that'll do it. We're just gonna keep adding things, you know? Okay, this will be... I need that one. Now, how tall up did I make this one in total? This should be apparently 30. I don't feel like that's right. Let me check my real life object. Well, it is just taller up. Does it need to be taller up? I don't think so. Maybe I'll make it less than that. Maybe I make it be 30. So this will actually just be 10. There we go. So that's the entire section that slides. Now I do need a spot for the rubber band, or the rubber band singular rather. But I need a way to put it so it doesn't like slide in the mechanisms that, you know, and then cause jams. That's what happened with the old one, is that I put it, if you look here, I put it like within this, but then by doing that, it rubs on like this corner and it rubs like on the inside, which adds so much friction that it like really just slowed it down. And so, oh, maybe 30 is too short. Maybe 40 is right then. Oh, you can see my Steam stuff. Wait, I should quit Steam. How do you do that? Exit Steam. Here we go. Bye-bye, Steam. Okay, where was I? Rectangles and squares and circles. This circle, I don't need it to actually exist. So let's just get rid of it. Center rectangle. I can't select the center of my circle. Interesting. Great. Alright, never mind. We're not going to create a sketch from there. I'll actually create a sketch from here. Nope, I don't want that. I wanted a rectangle. Oh, it has to be parallel and whatever. Okay, we're going to actually get ourselves a polygon. Yeah, that's a wonderful idea, me. And then it's actually 4. And then I can go like, how do I get it to be a perfect, like, actually it doesn't matter. I just need to pick a size. Yeah, that'll be fine. And then I can dimension this and this. I want it to be 135. There we go. And then I can extrude this and that. -10. Perfect. Wow. Look at how printable that is. Wow. Okay. Actually, this is really stupid. Oh gosh. Big loud truck coming by. Thank you, Taiwan. Yay. You know what? Let's say that I'm gonna get us some water. I'm thirsty. Believe it or not, local streamer drinks water without needing to be donated. More news at 5. Okay, my water bottle does not stink yet. That's good. There we go. All right, I have refilled my water bottle. I don't have like tap water that is safe to drink, so I just have a like 2-liter jug of water. Yummy. Water drinking ASMR. How wonderful. Okay. All right, where was I? I need a rectangle that does things. I don't need that sketch anymore. I don't actually need a rectangle. Where was I? What was it? Where did that rectangle come from? I don't need a rectangle. What I need is to build all of the features that I put into this grabber. Meaning I need my belt slot. I need my little hook. I need my rubber band thingy. I need my badge holder. And I need my end stop switch. And I'd somehow need to do all of that. Oh shoot, I can extrude this more. No, not that one. This one. It's gonna be 20. Let me hide Bunny one again. There we go. Check that out. Wow. 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 Okay. Wow. Let's see here. I think if I did my mathematics correctly, which I don't do always, my belt should just, well, it's not even mathematics. It's just, that's just how it is. My belt goes there. Oh, shoot. Uh-oh, chat. It looks like the belt is a little bit more, oh wait, no, the belt, wait, huh? Okay, why is this one so much wider than the other one? How wide is this? How wide is this? I need to grab this line and this line. It is 71 millimeters wide. Does that even fit in one of these spots where the hypothetical bin goes? That is 75. Oh, I guess I have 2 millimeters on each side. Yeah, that's fine. Right? Surely that's fine. Wait, what if I printed these bins in vase mode? That would be so good, actually. Wait, why didn't I think of that? Okay, well, chat, I know how to make a bin now. Vase mode. Cool. Anyway, where was I? We were complaining about how annoying the belt is. Right. Okay, so the belt, it seems, is about, that's not how you grab two things. 15 millimeters off from where the whatchamacallit is. And then if I take yeah, look, can I measure what if I ooh, what is this? Ooh, what's this? Oh no, I want to measure. No, okay, never mind, everyone. Let's see here. Let's just create a sketch, then I can see how many millimeters. Looks like 2. Not too hard at all, I guess. Not too hard. Ha 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 ha. So 2 millimeters off from that. This raises a little bit of a concern here. Do you see how it's flush? Just like Balatro. Okay. Well, what if we threw this grabber out and made a version 4? I don't want to redesign my gantry, but the belt kind of has to go there. It has to be there, you know, it kind of has to be there. So what now? Yo, ruh-roh, raggy. Ruh-roh. Okay, let's see. Belt goes here. So here's an idea. This can be the side that we print, and I will make this just flat. We put the belt in, and then the grabber goes in. Or maybe I just don't even think about it like that. Let's see. How far off is that? We don't need to show the snap points anymore. 25, huh? That's 20. Okay. So I get 5 millimeters. So what does that mean? What does this mean, everybody? This means we need to go back to this sketch and adjust it. So what if I move this by let's see. How would I do this? So the belt needs to go there, basically. Dang it. Can I not escape from this? Am I locked into doing the sketch forever? Okay. I figured out the button, guys. I figured it out. Oh gosh, I'm way exhausted. Hey, I know you might not enjoy this, but what if I played some video games? What if I played some video games? Are you guys interested in seeing me lose in Celeste? No. Are you guys interested in me losing in Guilty? No. What else is there that I can do? I'm exhausted. Let's see. I could keep working on my card sorting robot. That's a good idea. Oh wait, that's right. I need to make the camera mount for my smartphone so that I can do this stuff in real life. Oh yeah, that reminds me. I have a math problem. All right, everyone, I have a math problem. I know. Oh, that's the Windows. Oh no. Okay, great. I figured it out. I figured out my own keybinds. So everyone, we want to figure out this math problem. I have a mathematical problem. It has to do with maths. So here's my math problem. I have a joint, and on that joint I have a bar, right? Now this bar is loose, so it exerts torque onto the joint, right? Now this torque varies based on the angle of the bar, right? Because of gravity, there's always the downwards force. The force is always down. And so the force vector on, or the torque vector, is whatever the math is. It's this, or whatever angle. This will be angle of bar. I don't know how to do the math, is why I'm asking you the question. But basically, this torque vector is trigonometry. So, I need to figure out how much force will that apply, or how much torque rather, does this apply? Okay, we always know this distance. This distance will always be n, distance of n, right? And then this torque, we don't know. We don't know because it varies based on the angle. So let's look at a triangle, right? This is a triangle. So SOHCAHTOA, this is H. This is, so H is our torque vector. I mean, our gravitational force. H is gravitational force, right? H is equal to gravity. I'm gonna write this very pretty. There we go, look at that. Wow, I'm so good at writing with the mouse, guys. Let me switch mice real quick. Okay, so H is gravity, right? So and then this angle, which angle do I want to grab? You know what? I can only undo 3 times in this version of Microsoft Paint. So, you know, so then it applies the torque, and so this applies the torque, right? Okay, so this is a joint. So I need to figure out, let's just call this, and then this is our right angle here, right? So So this is our right angle, and then, wait, shoot, that's not it. There we go. So this is what applies the torque, right? So this is our angle that we're at. Now that angle is always the same as this angle, which I think will be useful for the second part of this question. Let me write big math down here. Math warning. Okay, so mathematics, right? Everyone loves maths. So we have this angle, and we have this triangle. I'm gonna draw the triangle here. It's this, right? This is our triangle, this is our right angle. This is angle, we're gonna call it angle theta. That's not how you write theta. I don't know how you write theta. We're gonna call it angle A. This is distance n. And so since torque is, you know, n times, or no, this is distance L. L. Since torque is L times force, right? We're gonna use Newton meters because it's easier. Newton meters. And so like the question here I'm asking is like, how do we calculate the amount of force that we will, so let's say that we have a mass M here at the end of this. The mass will always be the same. And so like, how do we calculate the torque done based on the angle? Because here's my idea. Here's why I'm wondering about this math. Let's say I have a weight, right? Let's say I have a mass of a constant number. We will call this E. A massive constant E. And then I have it, you know, around that, so it applies a constant force, right? Then on my hypothetical, you know, beam, I say it's like this, right? Something like that. Now, I would like to use this mass E to make it such that this will always have a net torque of 0, if that makes any sense. So I want net torque of 0. Now, the reason why, because it changes, right? It changes based on the angle. But because it changes based on the angle, what I'm thinking is like, what happens if I have a cam profile, right? What if it looks like this? Or something like that. So when it is flat like this is when it has the most amount of torque, right? So it will have the most amount of torque in the cam profile. So it will look like something like this, right? Or maybe not like that, but like this. Like an egg. Or no, it wouldn't look like an egg. It would look more like this, actually. No, hold on. It would look more like this, an oval around the, there we go. And then this would go to our mass E, right? Because then if it's at this angle, it doesn't need as much torque to counteract the torque. So then it would instead be like this. And then it would be taking, you know, from a different profile. I don't know. This is entirely hypothetical, and this is why I want to do the maths for it, right? This is like, doesn't even work like that? No. No, it doesn't work like that. Will it ever be able to work like that? Maybe. I don't know. Like, how do I get the other question is like, how do I get this profile out of the way as it is like, there's gonna be some curiosity with the, because like, if you think about a cam, right? It looks like this, right? And it rotates around here. Or here, let's get a bigger one. Nope. 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 There we go. We got our cam, right? If we have a string that goes like this, even if it rotates a little bit, it'll still be contacting the outside face for a while. So like that's another consideration that has to be made. So basically this is my math problem. Wow, I need to, I want to figure this out. If any of you know how to figure this out, that would be excellent, because then I don't have to do it. I mean, it's probably just some simple trigonometry or some like vector, whatever. This is stuff that I did in high school and I forgot about it. It shouldn't be that complicated. It's not that complicated. But I'm a computer science student, so let's just say not my area of expertise. Let's see here. I mean, okay. So basically, if I think about it right, when it's like this, net torque needs to be at 0. Oh, the torque on the mass, well, the torque exerted by the mass, or the torque exerted by gravity on the mass at the top is 0. Meaning it should be completely flat. Or like, if this is the joint, this should be the string, the like weight E, right? So then I'm also wondering something, is it possible to, wait, hold on. Is it possible to make mass M and E like correlated with each other, where if I need to increase mass M, I just increase mass E instead of having to print a new profile of what's it called? And then I'm wondering, is it possible to link multiple of these together using either the same mass E or multiple mass E, right? Like, what if that's possible? But it should be 0 there, and it should be effectively 100 here, right? So somewhere there's a curve. So like it should look like this here, right? So somewhere there's a curve in between just a line, or maybe it is just a line. I don't know. Oh, I got a notification on Discord. Wow. Okay. So mathematics. Fun. I don't know. We can worry about this another day probably. This is just a curiosity of mine. I think in the meantime though, I am going to design myself my camera mount because it is probably pretty simple. Let me go grab my aluminum extrusion pieces so I know what I'm working with. I think I've got like 2 long ones and like 4 short ones or something like that. So, or maybe I'll just call it. I don't know. I'm really kind of not feeling it today. I mean, it's been an hour. An hour is good. An hour of work. I got this and then I realized that it was fundamentally flawed, so I might just do it. I throw it out, starting the 4th one. Why not? I could play Donkey Kong Bonanza. Here, what games do I have on my Switch? I've got Celeste. That's what I was playing right now. I've got Nintendo Switch 2 Welcome Tour. That game's fire, by the way. I've got Mario Kart. I've got Okami. I don't know. Not really sure streaming a video game is a great idea right now. I could play Guilty Gear. No, I don't want to play Guilty Gear. All right, great. That's all. I'm gonna call it for today. Thanks for watching. I'll see you again eventually. Let me figure out where paint is. Thanks. Hold on. Let me write my T good. Wow, there's a cool T. Thanks for 4. Yes. Oh yeah. Oh yeah, that's what we're talking about. Watching. Ooh, I'm getting better at this. All right, thank you for watching, everybody. I'll see you again very eventually. Oh, all right. Story time, actually. Story time about work. Story time about work. I actually want to tell a little bit of a story about work. Okay, it's not over yet. We're gonna yap a little bit. So, what happened at work? What do I do for work? I am right now at what is essentially, it's not essentially, it is. I am at what is an English school in Taiwan, and I teach kindergartners using English. I'm not teaching them English. I am teaching them random stuff about culture, but I am doing it through the medium of the language English, right? And so it's interesting. I've never taught kindergartners before. I haven't gone to college to learn how to teach kindergartners, so I'm completely out of my I'm in school for computer science, right? So no matter what I'm doing, I'm always out of my field. It's great. I highly recommend you do that every single time, by the way. So, since I'm out of my field, what does that mean? That means that I don't know what I'm doing. And these kids also don't know what I'm doing. So, it's kind of wild. Recently, okay, so last Friday, actually, I don't know if I should say this. I'm not gonna say this. I'll tell you guys in the future, in a long time when, I don't need to worry about it anymore. But, okay, so, on Monday, I was assigned a new class of kids, right? And they were a heck of a lot more well-behaved than the last time. So 1 week ago, I was first time teaching, right? And those kids were wild, crazy, running around. Now the new class was very well behaved for at least the first couple of days. I feel like I ruined them. I ruined it, everyone. I ruined it. But anyway, for the first couple of days, they were very well behaved, and basically, the biggest issue I had was that my curriculum was not exactly well planned out. As in, the school has one book, and it was double booked, basically. Like, the book was double booked for the classes. Now, it could have been completely solved by simply just switching the book, you know, per day for a couple of the classes, but no, that's not what happened, apparently. So basically, I had to figure out how to entertain a bunch of rowdy kindergartners for an hour before we could actually start the class, because then we'll actually be able to get our book. So here's what I did. Day one, the class topic was about American food. Luckily, I'm American, so I was able to yap about, "Hi everyone, I'm Teacher Jack. It's nice to meet everybody. So, where do you guys think I'm from?" And then they said, "Canada." And I'm like, "Canada's pretty close. That's pretty close to where I'm from." And then someone said US. I'm like, yeah, I'm from the United States. That's right. I'm American. I'm American, everybody. Shocker. So I said I'm from the US, right? And then after that, I was like, okay, does anyone know what state I'm from? They said, Canada? No. Canada's not a state, buddy. Canada's its own country. Okay, I'm not from Canada, okay? And then they said, Texas? I'm like, now I don't sound like this, do I? No, I don't. I sound like this. It's very obviously like a Pacific Northwestern, or at the very least, West Coast accent, right? And then, I don't remember what other guesses they got, but eventually I steered them towards Washington State. And then I started talking about burgers and stuff, and it was great. I love burgers. Burgers are wonderful. And then I finally got the book, and then they handed out like burgers for me to cut. So like the class is supposed to be about like learning about different food cultures from around the world, right? And so the first day was burgers from America. Now about these burgers that they gave to me to give out, I wouldn't. Okay, if you gave me that and said, "Hey, I got you a burger," I'd be like, where did you get this burger from? Because let's just say it maybe wasn't really burger colored or burger. Okay, let's say the most adjacent thing it had to a burger was that it was meat patty between two pieces of a type of bread. So it was essentially, it was closer, I would say it was closer to a McMuffin with cheese than it was to a burger. Actually, it's essentially, literally, it's a McMuffin with cheese, but with a little bit more filler in the patty. That's what I'd say it was. And so I'm like, yay, everyone, look at this burger. I thought it was, I didn't know it was a McMuffin with cheese until I opened it. But before I opened it, I was like, all right, everyone, we've got burgers for the class to try. Now, we're gonna start by drawing on the whiteboard, what do we think is gonna be in the burger? And then they're like, ooh, lettuce, cheese, pickles, onions, I don't know. They said random stuff. Sprinkles, you know, kids. And then I opened it, I'm like, oh. And then I showed them. I was like, what's in this burger? And they said, cheese. I'm like, yep. Anything else? Cheese. Yeah, so there wasn't anything else in the burger. And it was great because there are 11 kids in the class and I got 2 burgers. So I cut each of them into 6. And then there was one extra slice, right? You know, the dreaded one extra slice. And so I was like, okay, what do I do with this now 1/6 of a burger, right? I have 11 kids, 8 of them who want another slice, and I've got 1 slice. So after much debate, we ended up playing Simon Says, right? And now maybe Simon Says was not the best idea because it's a little bit unfair, you know? But anyway, we played Simon Says. Now the kid who sparked the entire thing really wanted the burger. There was one kid who really wanted the burger piece, right? And she was the first who asked me, hey, can I have another slice of burger? I'm like, sorry, I only have 1. I have to make it fair for everyone. And so she lost. And so while I'm trying to run a Simon Says game with a bunch of other children, she's like up at me and she's like, can I have the burger slice? Can I have the burger slice? I'm like, no, I have to share it. It has to be equal, okay? Everyone has to be able to have their fair shot. So I'm still running this Simon Says game. Eventually, someone wins. I give them their burger. Everyone's fine with it, I guess. She's still hungry, of course. Lunch is happening in 30 minutes, so it's not that big of a deal. But anyway, lesson learned, don't run Simon Says or maybe just cut the burger into 5 and give some kids extra burger and just pretend that it didn't happen, or have an even number of kids in class. Anyway, let's see what's next. What happened next, everyone? Next up is Tuesday. Tuesday, the same thing happened. Book not available. So what did I do? What did I do? Hold on, chat. I need to remember what I did. Oh yeah, same deal. No book. That's okay. I'm like, hey, no book is fine. I can simply just yap again. Luckily for me, today we were talking about maple syrup in Canada. So I started the day, I was like, hey everybody, do you remember where you thought I was from? Canada. They didn't actually say Canada. They didn't remember that. I was like, Canada, right? Everyone thought I was from Canada? And they're like, yeah. So then I went to Canada. I'm like, all right, everyone, does everyone want to learn a really weird fact about Canada? Or actually, no, I started the day by asking everyone, hey, so what do you think of when you think of Canada? then they said like hockey, beavers. I don't think anyone said beavers actually, which is weird. They said a whole bunch of random stuff, and then finally someone said maple syrup, and I'm like, yeah, maple syrup, that's a good one. Then after they said maple syrup, I drew the maple syrup on the board. Now I'm a horrible artist, horrible artist. Right. So it turns out looking silly. Everything I draw looks silly, and so that's the running joke. Can't draw, but that's okay. And then I'm finally out, like, done with that little bit for 10 minutes, because remember, I have to burn an hour. So then I'm like, okay, everyone, now, you want to hear a weird story about Canada? Now, I vaguely remembered the details about there being a maple syrup, like, Canadian maple syrup reserve, right? So there's the warehouse of maple syrup. There it is. Yes. So it's really funny. But anyway, I told them about the maple syrup reserve. I think they thought it was interesting, or maybe they didn't think it was interesting. I don't know. And then I don't know. Well, maybe I'll save the story for another day. I think it's interesting enough to tell another day. Anyway, I'll see everyone later. Bye bye. I'm going to bed. I'm not going to bed actually. It's 4:17 in the afternoon. No, I'm going to bed later. Much later. So yeah, I'll see y'all later. Bye bye. Bye bye. Oh, there you go. Thanks for watching, everybody. Thanks for watching.